We can't do that with an element, only a molecule. So what we're looking at is matter being made up of molecules and elements. Well, what are molecules and elements made up of? Well, molecules and elements are made up of atoms. Now, atoms, and y'all have seen representations of atoms. You know, basically, it's got a center section, and it has these things that are orbiting around it. You know, we've seen this type of diagram. Well, this middle part of the atom is called the nucleus of the atom. Now, there are subatomic particles that make up the atom. And look, folks, understand there is a heck of a lot more atomic theory than what I'm going to share with you. This is just to give us the basic understanding so we can do well throughout this basic DC circuits course. So in this nucleus, the center portion of the atom, are two subatomic particles that we want to be aware of. In the nucleus, there is the proton and the neutron. So in the nucleus, we've got the proton and the neutron, and then orbiting. Now, this is a key concept you have to understand. Orbiting, like the planets around the sun or the moon around the earth. Orbiting around this nucleus is our third subatomic particle called the electron. And the electron is the particle that we want to concentrate on. If we get into the nucleus, we're dealing with nuclear energy, and that's not for us. We're simply going to control the flow of these electrons. So the outermost, or the particle in the orbits itself, the electron. Now, you got to understand, there's a couple of things going on here that we need to understand. First of all, the nucleus has the proton and the neutron in it. We don't deal with that. And then orbiting around it is the electron, and that's what we're interested in. But we have to understand, we got this middle thing and these things flowing around it, right? They're going around it, orbiting back and forth. Well, there's a couple of forces in effect there. One of them, I want to let you know, is actually the centrifugal force. Now, the centrifugal force, I got a little bolt on the end of this little wire, and I'm going to take it and I'm going to spin this bolt. And you'll notice the bolt stays at the end of the wire the whole time. Now, if it quits spinning, it falls down. But as it's rotating, it is maintaining that outer diameter as it goes around and around and around, all right? So another thing you need to understand, that as I am spinning this, if I were to let go of the wire itself, the thing goes fine. I know it kind of looked like I threw it, but so if I'm letting it, and I just let it go, well, it just goes flying everywhere. So understand that as these electrons are going around this nucleus, I have that same centrifugal force wanting to push that electron out of its orbit. So I got to have some way of holding on to that piece of wire. Same thing with a bucket of water. If I got a bucket half full of water and I sit here and start spinning that bucket like this, well, when it's up here like this, I'm not going to be getting wet. But if I take and let my hand loose of that bucket's going to go flying. So not only do I have the centrifugal force of the orbit around the nucleus, but I got to have some other force that's hanging on to the handle of that bucket. To keep that electron in that orbit, I got to have something hanging on to the handle. Okay? So first of all, I want you to know that we have that centrifugal force. That's the same force if you ever been to the fair and rode that ride. You know, you get on it, it pushes you up against the back, you can't hardly move, and that sort of thing. So that centrifugal force wants to fling that electron out. So what is it that's holding on to it? Well, you know, when people discover things, they don't set out and go, well, I'm going to make this discovery right here this morning. No, what they do is they do things called experiments. They say, well, maybe I'll mix some of this with some of this, and mix some of this with some of this, and heat it up and see what happens, or put some of this with some of that and freeze it real cold and see what happens. So through experiments, they discover things. Now, one of the experiments they did when electricity was young is they had these atomic particles, subatomic particles, electrons, protons, and neutrons, and what they did was they had a post, a metal post, and they put an electrical charge on it. Now, what they found out is as they beamed electrons past this post, they found that those electrons were pushed away from this post, okay? But when they beamed protons or at this post, or toward the side of the post, they found that these electrons came in and were attracted toward the post. Now, the electrons were forced away, the protons were attracted to it, and then neutrons didn't even do a thing to them. So they didn't really know what was going on, but they did recognize that the electron and the proton acted oppositely. The electron was forced away, the proton was attracted to, and then the neutron didn't do anything. So they decided that they would call this an electrostatic charge of each individual particle. And what they said was, protons, they were attracted to it. They said that's a good thing. That is a positive static charge. Positive charge of the proton. And we use a plus sign to represent the positive charge. The neutron, no charge. Or they would be considered neutrally charged, no charge or neutral charge. So the proton has a positive charge, proton positive, see how that works out? Neutron, no charge, or neutron neutral, pretty easy to remember. And then the electrons, those were forced away. They said bad news, so that was named a negative charge. So the electron is considered to have a negative charge, and we use a minus sign to represent that negative charge. So the atom itself has a nucleus with a proton and a neutron with an orbiting electron. We discovered that electrons have a negative charge, protons have a positive charge, and neutrons have no charge at all. All right, get this copy. All right, so we're going to pause there.